What's up everybody, this is Zach from SqueakyCleanCode.com and I'm really excited to be doing my first video tutorial for you guys. Today I'm going to talk about the builder pattern. I'm going to talk about what it is, how to use it, and I'll be implementing everything in Java, but this pattern is definitely 100% applicable to many other languages. So if you're going to watch the video, try to focus on the concepts rather than just the syntax, and then you can try to transfer it to any other language of your choice. So let's go ahead and get started. So here's a quick overview of what we're going to talk about in this video. I'm going to tell you what a builder is. Then I'm going to go through and explain why you should care. Why am I even making this video? I'm going to give you some examples of how you can actually use it, doing both examples of what bad solutions look like that we're trying to fix, as well as how you can actually use a real builder. And then we're going to clean it up even more using an external library called Project Lombok. And you can get this free online. I'm not going to show you how to get that library, but I'll show you how to use it. So what the heck is this builder thing that I've been talking about? So it's one of the original Gang of Four design patterns, and the Gang of Four are the four authors of this book that I have as an image here. They wrote this book, and it's a classic text on how to write reusable code that other developers can understand. And we can also use the builder to ensure that we're adhering to the single responsibility principle. This is one of the fundamental principles of clean software design. And basically what it means is that a program element, whether that be, a class, method, module, etc., should only have one reason to change. In other words, it is responsible for a single functionality. So touching back on the SRP, a builder is a way to create a separation between creating an object versus what that object actually does once it exists. In other words, we're going to create a class that doesn't need to know how it's created, or it should not play God, so to speak. And also in creating this builder, we can make some great headway in making more readable code for the client that uses the class that you're creating. So you may find yourself wondering, what problem does the builder pattern actually solve? I'm going to go ahead and walk you through two examples of bad designs that we can use a builder pattern to really clean up what that code looks like and make it more flexible and maintainable. So here's one example of a bad design that we can avoid if we use a builder. Essentially what we're going to do is we can create a class with all fields being publicly accessible. And whether that be actual public members or if they're private that you can access with getters and setters. So what this actually does is it allows us to create a pretty flexible object. We can set any subsets of the fields we want as we're creating the object, so it's really flexible. On the other hand, doing it this way is not safe because the fields can be updated at any point throughout the object's actual life and execution. So let me show you an example of where this design falls apart. So I've gone through and sort of stubbed out the base for the example I want to work with throughout the entirety of this tutorial. Basically, we're going to have an enemy, and the enemy's going to have some armor and a weapon. And I chose this example because it should be fairly easy for you to sort of visualize what's happening. It's a pretty canonical example of an object. So we've got an enemy here, and we've got a few default values. So this makes it so that we can construct this object, and all of these public members are already automatically set to some default values. Then we've got some basic functionality here that I've already gone and implemented. So we're going to have this display enemy bio method that's more or less just going to say, hey, here's all my information, sort of like what may be hovering over a non-playable character in a video game. We're going to simulate rendering the enemy, actually drawing it with the graphics engine, and then also simulate just attacking with some simple print statements. Also, let me just quickly show you what I've got in the armor and the weapon class, basically following the same design principle of we've got public members that are accessible. There's only one default value here, being the type, and we're just going to say, it's a naked enemy. They don't actually have any armor, so they don't have any helmet, arm, leg wear, footwear, etc. And I've got a simple toString method here, and then similar concept with the weapon. So, if they're not holding a weapon, they just got some bare hands, and it has no effect on their speed or damage. Also just as simple as toString on this one as well. So let's go through and actually see what it looks like to implement this enemy interface. So we've got standard main, and I've created a method here, just a static make anonymous enemy. So what we're going to do is we're just going to create an enemy, aptly named anonymous enemy, and we're going to say it's a new enemy. And that's all we really need to worry about, because we have all of those default values set to what we need them to be. Now we can display that enemy's biography, and if we run it right now, you can see right here we've got everything about that enemy, and unfortunately he says he's going to attack us now. So that's not good, but the code works as we expect it to. We've got the anonymous enemy, the level 5, they're naked, and they've got bare hands. So now here's where this design becomes bad practice. I've already just said that I can display this enemy's bio, but there's nothing stopping me, the client, from saying anonymous enemy dot level equals 5,000. And now we can say we're gonna render it, and we're gonna have it attack you. I'm gonna save this, I'm gonna run it. So we get the output that we expect, but the problem here is when we displayed this enemy bio to the user, it was under the pretense that they were a level 5 enemy. Now all of a sudden we've said they're level 5,000, and then we've rendered it and attacked. We've essentially lied to the user, and they're not going to be very happy about that. So what does it look like when we actually want to overwrite some of those default values we had set? I've skipped ahead and I've already implemented a make dark wizard and make silver paladin method just to sort of illustrate these concepts quickly to you. So we've got the dark wizard here. We've actually set their name so that they're no longer anonymous, and they're level 20 rather than the default level of 5. Then we go through and also manually create the armor, setting all of the stuff that the wizard's going to be wearing. So they're wearing baggy robe, sleeves, they got a pointy hat, and cloth boots. They're going to be holding the Elder Wand, and we're saying that that wand makes them a little bit faster and allows them to do a little bit more damage. And then we're putting that armor and that weapon back on that enemy instance. And then we're able to actually display that bio for that dark wizard. Similarly with the paladin, we're saying that they're level 15, wearing all this fancy knight armor. They're carrying a long sword that makes them slower, but makes them also do more damage. Putting that armor and that weapon on the enemy, and we're able to display that bio as well. Let's go ahead and run it. And as we expect, we've got our anonymous enemy still with all those null values. Now we've got our dark wizard, level 20. So they've got all of these different things on them that we just set. We didn't give the wizard a shield because why would a wizard have a shield? The paladin, on the other hand, has got everything set. So this is part of the beauty and that flexibility, that we can pretty easily choose which of these different fields in the armor class or the weapon class that we decide to actually set differently from the default values. But we also run into the same problem where we can update some of these after we've already displayed the enemy's bio. So just a quick recap on why this is a bad design. Back to the enemy class. It's a bad design because once we create this enemy, we can pass it in and out of methods, and it's dangerous because any one of those methods could be modifying the state of this data without us necessarily knowing. So that's where it gets dangerous, and why we have the motivation to try to create these immutable objects that once they're created, we can do things with them, execute their behavior independently of what data they were instantiated with. Alright, now let's talk about another bad design choice. Let's actually make all of the class's fields private and final, and then we can use custom constructors to actually set the data when we create the object. The pros to this are that we do create an immutable object, which is, half of what we wanted, but on the other hand, we'll end up with too many combinations of parameter sets. What I mean by this is, for example, say a class has two fields x and y. We would need to create 3 different unique constructors, one that takes just x, one that takes just y, and one that takes both x and y. And what this leads to is fragile code. Anytime we need to add another field, we need to exponentially increase the number of constructors that are needed to make this class complete. Alright, so let's see what this solution looks like in the code. I've updated the enemy class here to, like I said, make all of the fields private and final. And then I've also added just the one constructor here for simplicity for the sake of this example. But we've got a single constructor that takes every single one of those fields as parameters. Similarly, we've got the armor constructor that takes all of the armor's fields, private final. And same with the weapon, private final and custom constructor. So now let's see what the updated client interface actually looks like. We've got the more or less same implementation of creating our enemy here, but we're getting an error when we say new enemy. And that's because we need to use our new custom constructor. And in order to do this, we actually need to forward declare the armor and the weapon. I'm going to go ahead and paste this in here just to save you some time of watching me type it out, but we've got a new armor with all of the attributes of that armor, and a new weapon with the same attributes. So now we are ready to go ahead and plug this into the new enemy. So we're going to say that again, we've got our anonymous enemy, level 5, and we're going to give it the naked armor and the bare hands. And you'll see we're no longer getting that error. So now we've achieved what we wanted in that if we try to uncomment this code here where we set the level of the enemy manually, it's going to not like that because we made this private and final. So this is good. We've sacrificed some of the flexibility of the code and made it more rigid in that we've got these more explicit constructors, but the enemy that we're actually instantiating is safe from modification by other methods, classes, etc. Now, just as a couple more examples, you can see what this design looks like with the Dark Wizard and the Silver Paladin implementations as well. So you see lots of declarations of the different types of armor, the enemy, all these different constructors, so you can kind of see how this code gets pretty ugly pretty quickly, especially when a class has a large number of fields. So now let's get to the good stuff. How can we actually implement a builder? What we're going to do is we're going to make the constructor private as far as the interface's perspective goes. And what we're going to do instead is we're going to expose a public static inner class, and this is what's actually going to be called the builder. And we're going to use that builder, and it's going to be entirely mutable, allowing us to set all the properties that we need such that we can essentially copy over all of that data to create our immutable instance using that builder as the constructor parameter. Alright, I just did a lot of talking. Let's see what this new builder interface actually will look like. So we're going to need to define that public static inner class like I mentioned. So just paste that in, and we're going to call it the builder. So what this builder has is a set of fields that mimic what exists in the enemy. So where the enemy has private and final, we're going to have just standard public fields. And now we're going to update our constructor to actually take in that builder. So now we just need to specify that we're copying this data from the builder's properties. And that's essentially it as far as our constructor is concerned. And then from within our builder, we can link to that constructor as well. So we're going to have a method that returns an enemy instance called build, and it's going to return the new enemy, passing itself as the parameter to the constructor. And now what we're going to do that kind of leads into the magic of how the builder actually looks like to the client, we're going to create a method for each individual field in this builder. Now pay attention to what this actually returns. We're going to have a public builder, and we're just going to have the method name be the same as the field name. We're going to call it name, take a value to set that name, set the name, and then return this. So what this does is it's going to allow us to chain all of these methods together in any order we want. I'm just going to go ahead and paste in all of the other methods. Alright, so you can see that they're pretty much all the same. We've got the level, the armor, the weapon, where essentially what we're doing is we're just updating the builder properties along the way and returning this. And one more thing we can do to make the interface a little bit more friendlier is to give us quicker access to that builder. So we're just going to say, give me an instance of a builder, and it's going to return this new inner class. We're actually going to need to make this static though, indicating that we're able to call this method without actually having an instance of the enemy. So now back to our implementation, you see we can't really use this constructor anymore. So let's actually use our builder and see what it looks like. We're going to use that method that we just made to return the builder. And then we're going to string along this combination of parameters. So we're going to say name, give it the name, and this is why we were returning an instance of the builder with every method, so that we can just go dot this, dot that, dot this. And then level, armor, weapon, and then finally give us our actual enemy by calling .build at the end. So now you can see we sort of have the best of both worlds as far as our first two bad design choices go. If we come in here and try to set one of these members manually, so it's not going to let us because those class members are still private and final. And similarly, we still have the same flexibility as the first example, because we've got our enemy class that we can add or remove fields as necessary and not necessarily break every single piece of code that uses it in the process. So now let's take our builder and make it squeaky clean. We're going to do this by using an external library such that we can leverage the work that someone's already done for us. You may have noticed it can get kind of tedious to update every single one of those methods every time we update the members of the class. Now on one hand, this is still pretty manageable because you only have to make changes in one source file, but at the same time, all of that extra noise can sort of clutter up that source file. We're going to use an open source library called Project Lombok to take care of all of this work for us. And what Project Lombok is actually going to do is it's going to generate all of that noisy code for us at compile time and keep it out of our source file. So let's see what we can do to actually clean up this class. We're going to go ahead and delete all of this builder noise out of here, basically taking us back to where we were before. And you'll see we broke main, the code that was using this class. Well, watch how easy it is to fix main such that we don't have that error anymore. We're going to import a library, and then very easily just add this annotation here and save the class. You'll see we no longer have that issue with main. All of the code still works. So looking back at the enemy, we're down to 36 lines of code, where half the class before was just looking at the builder. And now that we know how easy that was, let's go ahead and do that to the armor and the weapon class as well. Now I'm going to show you a little secret here. I'm going to get rid of the toString method as well, because Lombok has an extra feature we can see. We're going to import lombok.builder. Now we're going to add 2 annotations. And there you go. That was all we had to do for the armor. We're going to do the same exact thing with the weapon. Now I've gone ahead and filled in what the main looks like using these 3 different builders, and we get this very fluent hierarchical sort of object instantiation, where on the very outer edge we've got the enemy, and then we've got for any given enemy we've got a name, level, an armor, and a weapon. But then say for armor we've got, we want the type, weapon we've got name, the speed modifier, the damage modifier. And this whole section really just reads like a very fluent paragraph. It's very concise, and we don't have to do any sort of guessing as to what values are indicating what. And it's also still very flexible because we can add or remove parameters from any of the classes as we see fit. And then just as a longer example, we can see what the Dark Wizard looks like, where we're adding more elements into the armor and the weapon. And that wraps up today's tutorial. I want to thank you all for watching my first ever video. If you find the time, please check out my blog at squeakycleancode.com. Go ahead and like and share this video and subscribe for more tutorials coming in the future. Given this is my first video, I'm sure you guys can offer me some valuable feedback on how I can improve and make these videos more useful for you guys. Thanks again.